This video is from the skill set Determining the Sample Space of Chance Experiments. This can be found within the Chance topic in the Year 7 Essential Assessment. And what we have here is just a few examples that I've taken from the Essential Assessment program. And we're going to look at this one here. List the sample space for the spinner with numbers from smallest to largest. So there's a few things that we have to consider here. What sample space is, what is sample space, and also when we find the sample space, putting them from smallest to largest. And sample space, the sample space just means what are the different possibilities that you can get from this scenario. And to be very specific, sample space doesn't necessarily care if the number appears more than once. You do have to consider them, however. Okay, so in other words, we have the number 1, 2, 4, 2, and 3, and we've got 5 spaces here to put in those possibilities. You just got to be considerate that we have to do it from smallest to largest. So 1, 2, 2 again, 3, and 4. Now finding these sample spaces are quite simple because the question will specifically tell you. You just have to be very mindful whether it's from smallest to largest or largest to smallest. The second example here, which is this example right here, says which sample space will give you a 1 in 2 theoretical probability of landing on the number 2. So let's assume that landing on the number 2 has to do with a spinner. And this right here, these are 4 different scenarios where there are sample spaces, okay? And some of them have more numbers and some of them have less. It doesn't necessarily matter. But in this case, we're looking for a 1 in 2 probability or a half probability, or in other words, a 50% chance of one of these spinners landing on the number 2. So in each of these scenarios, these 4 scenarios, the number 2 has to appear half of the times, or 50% of the times. In this scenario here, it appears twice out of 1, 2, 3, 4, 5, 6, 2 out of 6. And just to be careful, let's just make sure that 2 out of the 6, when simplified, can be simplified first of all, and when simplified it doesn't give us half, and it's 1/3. So this answer can't be the case. This one is a 2 out of 1, 2, 3, 4, 5 chance, which isn't a half, and this can't be simplified. This right here, there are 1, 2, 3 number 2s out of 1, 2, 3, 4, 5, 6. I think we found a half probability because here it's appearing 50% of the times, and 3 over 6 does simplify to 1 over 2. So this right here has to be our answer. And just to double check, 1, 2, 3, 4, this is a 4 out of 6, which is 2/3. So that right there can't be the answer either. So it has to be this one here. The next example, which sample space will give you a 3 in 4 theoretical probability of landing on the number 1? So like the previous example, sorry, but it's a 3 in 4 chance, or 75% likelihood of it landing on number 1. So we need the number 1 to appear 3/4 of the time, or 75%. This right here, there are 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, which is also the same as 2/3. 2/3 is not the same as 3/4, so it can't be the case. This right here is 3/5 and not 3/4, so it can't be this one. This one here, the number 1 appears twice, so 2 out of 3, so this is 2/3. Can't be this one, so we have figured it out by process of elimination, but just to make sure, 1, 2, 3, 4, 5, 6 out of 8, the number 1 appears, which doesn't look like 3/4, but just in case, it's good to double check. 6 over 8, it does simplify to 3/4, meaning that this one here has to be your answer. And this makes sense. The number 1 appears about 75% of the time from this whole sample space. So 3/4, 75%, this one here is your answer. The next example, and the last 2 examples here, we've got a question that says that selecting a yellow counter at random is 2 times more likely than which color? So we're going to select a yellow counter. Let's see how many yellow counters there are. There are 4 yellow counters. And we have to be very careful with the terminology that they're using in regards to how they're referencing these yellow counters. So it says here, selecting a yellow counter at random is 2 times more likely than which color. So that's saying that if I select a certain color, whatever color I select, this color that I select, selecting a yellow color is 2 times more likely to happen. And if there are 4 yellow colors all up, this would mean that the color that I have to choose, there has to be 2 of them. There has to be 2, and that's the only number that works. Because if I select a certain color, there's 2 of them, selecting a yellow color at random is 2 times more likely than that color because there's 4 of them. This color can't be 3, because if it was 3, then there would have to be 6 yellow counters, but that's not the case. All right. So we're looking for a color where there's only 2 colors to choose from. And in this case, it's green. It can only be green because green is the only one that has 2 colors. Can't be yellow, obviously, because that's the one we're talking about, but there's 4 of them. It can't be pink because there's 1. It can't be red because there's 3, and it can't be blue because there's also 1. So our correct response in this case is green. The last question. And these set of questions are quite tricky, and there will be a bit of logical thinking and a bit of problem solving that's involved with this. Okay, I'm only going to show you one example to show you how the context of this works. You will just have to try really, really hard for the next set of questions. And this question here, which spinner is 2 times more likely to land on pink than green, and equally as likely to land on orange than pink? All right, what is this saying? Let's look at this first sentence here, the first part of the sentence. Which spinner is 2 times more likely to land on pink than green? So if I were to select, and I'm actually going to get the color green here. If I were to select the color green, okay, let's get the color green. Which spinner is 2 times more likely to land on pink than green? So in other words, however many colors there are in green, there are twice as many of that color for pink. So for instance, if there was 1 green, there would be 2 pinks. If there were 2 greens, there would be 4 pinks, 3 greens, 6 pinks, etc. So with this scenario, this is the first clue, and we can try to eliminate as many as we can. Here we have 1 green, but we have 3 pinks, so this can't be the one. Here we have 1 green and we have 2 pinks, so it could be this one. 1 green, 2 pinks, it could be this one. And there are no greens in this one, and 4 pinks, so that can't be the case. So it can't be this one, okay? So we've eliminated 2 of these already just by that first chunk from the sentence. But then it says, and equally as likely to land on orange than pink. So that means whatever amount pink is, this is also the same as orange. So from these 2 scenarios that we have here, because we have 2 in each, we're expecting 2 oranges as well from the scenarios. This one doesn't even have any oranges, so it can't be this one. And this one here does have 2 oranges. So this here is our answer. And even though we have this blue one right here, this doesn't really make any difference. It doesn't hold any significance because it doesn't eliminate these two facts here. There can be any other colors within here, provided that there are 2 times more pink than there are green, and then the amount of pink and orange is also the same. So the next set of questions from this one onwards do get tricky. They are tricky. You just have to think really logically. It's recommended that you write all of these questions into your exercise book, and any working out should also be written as well. And this concludes this video. I'll see you in the next video. Until then, bye bye.